You sit down to work. The door is closed, the room slowly feels stale, and a task that looks simple starts feeling strangely difficult. Is that only fatigue, or can the air change how you think? 3 publicly available controlled studies tested carbon dioxide levels that can occur indoors. Their results are attention-grabbing, but they do not justify panic, a magic cutoff, or the claim that every bad workday is caused by carbon dioxide. Here is what the experiments actually found, and what you can reasonably do with that information. First, carbon dioxide is measured in parts per million, or ppm. People exhale it, so levels can rise when an occupied room receives less outside air. In real buildings, the reading is often useful as a ventilation clue, but it can also move alongside odors, particles, and chemicals affected by ventilation. That distinction matters. A monitor tells you about a pattern in that room. It does not diagnose brain fog, identify every pollutant, or prove that carbon dioxide caused a symptom. The first direct experiment, published in 2012, placed 22 participants in an office-like chamber. Each person experienced carbon dioxide levels around 600, 1000, and 2500 ppm in 3 2.5-hour sessions. The order was balanced, and both the participants and the person administering the cognitive simulation were blinded to the condition. The test was not a simple reaction time game. It measured 9 dimensions of complex decision-making, such as initiative, information use, task orientation, and strategy. Compared with 600 ppm, performance at 1000 ppm decreased moderately and significantly on 6 of 9 measures. At 2500 ppm, 7 measures were significantly lower. The figure makes the pattern unusually easy to see. Several dots move from average or very good performance toward marginal or dysfunctional ranges, but not every score fell. Information search did not significantly change, and the focused activity score increased. So the accurate headline is that most measures of complex decision-making worsened in this small experiment, not that all forms of focus collapsed. A 2024 experiment tested the higher contrast again with a tighter crossover design. 12 healthy young adults completed 2 sessions, 1 week apart. For 2 hours, they breathed chamber air at either 600 or 2500 ppm while completing different versions of the same strategic simulation. Because every participant completed both conditions, each person served as their own comparison. That helps reduce differences between people, but the sample was tiny, young, and healthy, and the chamber used added pure carbon dioxide rather than the full mixture found in a stuffy room. At 2500 ppm, scores decreased significantly in every one of the 5 domains examined: task management, focused activity, information management, crisis responsiveness, and basic strategy. The paired lines in the published figure show each participant moving from the control condition to the higher carbon dioxide condition. This is a striking result, and it strengthens the case that carbon dioxide itself may matter under these experimental conditions. It still does not tell us exactly how a particular meeting room changes your productivity, or what would happen at every level between 600 and 2500. A different 2016 study looked more like a workday. 24 professional-grade employees spent 6 full days in a controlled office. The researchers compared a conventional condition with higher volatile organic compounds, a green condition with lower compounds, and green plus days with more outside air ventilation. Average cognitive scores were 61% higher on green days and 101% higher on green plus days than on conventional days. Those dramatic numbers cannot be assigned to carbon dioxide alone, because the conditions also differed in volatile compounds and ventilation. The same office study also raised carbon dioxide independently, while other tested conditions were held constant. In its adjusted model, a 400 ppm increase was associated with a 21% decrease in average cognitive scores. Participants also averaged 25% higher scores with increased outside air ventilation and scored higher in 8 of 9 domains. Do not turn either number into a promise. They describe this study, this test, and this model. The authors also said that uncontrolled environmental confounding could not be excluded. Put the 3 papers together, and the sensible conclusion is narrower than a viral headline. Controlled exposures found worse performance on many complex cognitive measures as carbon dioxide rose, especially at 2500 ppm, yet the samples were small, the tasks specialized, and the exposure durations limited. The 2012 authors asked for confirmation, while the 2024 authors called for replication and dose-response data. These studies do not establish 1000 ppm as a medical danger line, and they do not prove one biological mechanism. The practical move is to use carbon dioxide as a trend, not a verdict. Notice when an occupied room climbs compared with its usual level. Where it is safe and suitable for the weather and building, follow the building's ventilation guidance. Increase outside air, use the mechanical ventilation correctly, or take a break in a better ventilated space. Do not promise yourself an instant cognitive upgrade, and do not ignore fire, pollution, heat, or security concerns just to open a window. Better air is a reasonable goal. These papers tell us why the question deserves attention, not that one number controls your brain. Every source and figure is linked below.